Okay, so now we're gonna go for the OS.H operating system. That's the kind of the core that integrates everything together. So as you can see here, we're gonna be including the list.h, the PCB.h, and the event.h. Once again, if not def OS, define OS, and here you have the end if. The operating system here is defined to be a struct, as you can see, along with functions that would be called to behave like an OS kernel. The operating system here is defined to be new queue, ready queue, running queue in case we have more than one processor, waiting queue, terminal queue, event list, number of CPUs that we're going to be using, number of idle CPUs, and clock. The queues we all know about what those are. They're pointers for linked lists. Each and every one of them would be considered as a linked list like what we have seen before. Number of CPUs, number of idle CPUs, those are parameters that are going to be assigned to the operating system. The clock is basically the simulation clock that we use. So basically it's the current time of execution. Here is the operating system. That would be the alias or the nickname of struct OS. So instead of writing struct OS, we're going to be writing operating underscore system. The methods that we have: event handler, start operating system, shut down operating system, run operating system, initialize arrivals, event handler, arrival event handler, dispatch event handler, exit event handler, IO request event handler. All those are events, and every function is a handler for them. IO complete event handler, time expire event handler, interrupt event handler, move process, this is very important, and print kernels. Many of those functions I removed the code for them because they're not really something that you would do in this project. So you will find most of them being left empty. So this is the operating system.h. Let's go now for the operating system.c. So here is operating system.c. We include the studio.h, stdlib, and then our list.h, pcb.h, event.h, and os.h. Those are 4 header files that we have included. Let's start operating system. What does it take? It takes the number of processes that you want to execute, the number of CPUs that you have, and the operating system itself that will run those. As you can see here, we're sending 2 stars because we want to send the operating system as called by reference, because it will change. When you started, things will change inside the operating system kernel. So here again we are creating the operating system. So operating system kernel equals operating system star mmalloc, memory allocation, size of operating system. And then here you have seen create list before in the list.c. So for the event list, we're creating a list for it. I'm going to tell you what an event list is now. New queue is a list. So you created ready queue, you created running queue, you created waiting. Terminal number of CPUs is the number of CPUs. So here it is. You send the number of CPUs and put the number of CPUs inside the kernel with the number you are sending. The clock is initially 0 because that's the start of the simulation. And if you remember, when we scheduled We started always with time 0. And then I call something called here initialize arrivals. Okay, we send the number of processes and the operating system kernel. Okay, we initialize the arrivals and then we run the operating system. Before we see what those are, let me talk about the event list. The event list is nothing but a linked list that has all the events to execute. And since we know the number of processes that will be arriving, we generate arrival times to the future. Okay, and each and every one of them will be randomly generated by time and is going to be put where it belongs. So the earlier the event is, the higher it is in the linked list. The other function is the shut the operating system down. What you do here is destroy list. The one that I told you we're going to be skipping it because it's not really important. All you need to know is that it's a function that destroys the queue. So in order to shut the operating system down, you destroy the new list, the ready, the running, the waiting, the terminate, the event list, and then you free the operating system. To print the kernel here, printing means you're gonna be printing the lengths of all the lists that we have. So you print the length of the event list, you print the length of the ready queue, the new queue, and so on and so forth. You print all the queues. That's all we need to know from the printing the kernel status. Now, if you want to run the operating system, what we sent here is the operating system itself as call by reference. Why call by reference? Because running the operating system will change the operating system. Now, you're gonna say here while not empty. What is empty? It's the function that we wrote in a list that tests whether the list is empty or not. So while not empty, operating system kernel points at event list. What does it mean? It means as long the list of events is not empty. What does it mean? It means that as long there are events to execute, continue, right? So this while loop will keep looping as long we still have events to execute. So here you say if the operating system kernel points to event list, points to front, points to item, equal, null. So as long it is null, it means there is nothing to execute. And in this case, you're gonna be saying fatal error. The event does not exist. Else, here, else, you're gonna take the event that you want to execute with the copy that I explained it before. Sorry, you first allocated and then you copy it. Okay, here it is, copy event. And then because this event is the event that's gonna be executing now, you adjust the clock to the time of execution. What does it mean? If you're arriving to my office, as an example, is an event, and I know that you will be on my office 3 o'clock sharp, as soon as you show up, I know it's now 3 o'clock. Okay, assuming that you're going to be showing with the exact right time. So this is exactly what happens. You put the clock to be the time of occurrence of the event. Okay, and then you call event handler. Okay, event handler. What is event handler? It's a function that I will explain it now. And then here you put the event list to be deleting the front, which is the event that you want to execute. Okay? So basically you do that each and every event that exists in the linked list. You take one, you interpret it, you execute it, and then you throw it away. Now, let's leave this for now. I'll explain it after I call the event handler. Look what the event handler is. Event handler, it takes an event and it takes the operating system kernel. And then I do switch type. If the event is arrival, let's do arrival event handler. If the event is dispatch, let's do dispatch event handler. If the event is exit, let's do exit event handler. If the event is IO request, let's do IO request event handler. If the event is IO complete, let's do IO complete event handler. If the event is time expire, let's do time expire event handler. And last, if the event is interrupt, let's do interrupt event handler. Okay? After you do that, let me first show you the code. What is the arrival event handler? Arrival event handler is basically moving the process from the new to ready. So what it does here is move process. You give the event ID or the process ID, sorry, the one that you want to move from the new queue to the ready queue. When you move the process from the new queue to the ready queue, the new state of the process becomes ready because it's in the ready queue. How about dispatch? Look at the dispatch here. Same concept. You send the PID that wants to be dispatched, and then you move it from the ready queue to running queue. What would be the state of the process? Running, because it's in the running queue. How about the exit? You're going to be moving the process from running queue to terminate. That's the exit, correct? So what is the new state of the process? It's going to be terminate. Then here the request event handler, I removed those because they're not part of your project. So I removed the code so you're not really confused with them. But simply put, here, if you want to say the IO request, this means the process will move from the running to the waiting with the exact same way that we did it before. How about here? Complete. It's going to be from waiting to ready with the exact same way. Time expire from running to ready. Interrupt event running to ready. Right? How would you move now the process? This is linked list stuff. You have here the source and you have the destination. You send the PID. All you do is find the process in the source that has this PID. You delete it from the source and you insert it in the destination. As simple as this. Okay. How about the stuff that I left? Let me go back and see what I have left in the code. Here in the initialize arrivals, I know the number of processors that we want to create. So for each and every one of them, I create an arrival event. Okay, I create the time of arrival for this event to be random. Okay, and then I put it in the event list, and I create a process and I put it in the new queue. Of course, it's in the new queue, right? And then the arrival event, that's the one that's going to move it, as I said, from the new queue to the ready queue. So I explained that. Here, as you can see, I'll take it from the ready queue, and if you have an available CPU, so idle CPU is greater than 0. In this case, you're gonna get the process and from the ready queue, and you're gonna create an event. What is the event? The event here would be exit, because it was from the if it's running, it's gonna exit soon. This is because your project is basically first come first serve, and it's assumed to be CPU bound, so all the other transitions do not exist. Okay, so the coming one is going to be exit. Of course, you're going to add the exit event where it belongs, so you add sorted, okay, and so on. This is basically, you move the process here from the ready to the running, and of course the exit event is waiting in the event list, so it runs until the time comes for the exit and it exits. Okay. So that would be it. Okay. Here, I think I explained the arrivals. It depends on the number of processes that you want to create. Okay. So having said that, we are done with the operating system kernel, and we're gonna see now the main code.